So, what is actually going on inside the mind of an AI? Today, we're going to look at a pretty groundbreaking approach that's not just about building a more powerful AI, but one that's actually structured a lot like our own brains. Let's dive right in.
Think about how you think for a second. When you solve a problem, different parts of your brain light up, right? One for language, another for logic. But what's happening inside a big, large language model? Is it this beautiful, organized symphony of thought, or is it just, chaos in a box?
And this really gets to the heart of the problem. On the left, you've got your standard AI model. It's basically one giant, tangled, gnarly knot of connections. Super powerful, yeah, but almost impossible to figure out what's going on inside. Now look to the right, the human brain, an elegant team of specialists, where each one has a very clear job. And that contrast, that's exactly what researchers are trying to fix.
Yeah, this whole tangled mess leads us straight to what everyone calls the AI black box problem. We can see the question that goes in, and we can see the answer that comes out. But everything that happens in the middle, it's a complete mystery.
So, here's the crucial point, right? If we can't understand how an AI gets to an answer, how can we ever really trust it? How are we supposed to make it safer or more reliable? This lack of structure is honestly one of the biggest hurdles in AI development right now.
But what if we could give an AI an actual blueprint for how to think? Well, that is the exact idea behind a brand new architecture, one that's directly inspired by the human brain.
And here it is, Meet Micro, which stands for Mixture of Cognitive Reasoners. The idea here is just brilliant in its simplicity. Instead of one giant, messy network, Micro chops the AI up into a team of 4 distinct expert modules. And get this, each expert is modeled after a major network in our very own brains.
So how does this team coordinate? Well, it's got a manager. There's this component called a router that looks at every single piece of information coming in and decides, okay, which expert is the best one for this job? It's basically a project manager for thoughts.
All right, so who are these specialists? Let's meet the team that makes up this new AI brain. First up, we've got the linguist. This one is modeled on our human language network, so think of it as the team's grammar guru. It handles all the fundamental rules of language, just making sure the sentences are built correctly.
Next, we have the logician. This is the real heavy lifter of the group, inspired by what's called our multiple demand network. It's the one that tackles all the tough stuff, like complex math, logical puzzles, and planning ahead.
Then there's the socializer. This expert mirrors our theory of mind network, which gives it this incredible ability to understand social context. It tries to reason about what people might be thinking or feeling or what they're planning to do.
And finally, we have the librarian. This one's based on the brain's default mode network, and it's basically the keeper of all knowledge. It accesses and connects these huge amounts of information about the world, kind of like you recalling a memory or a random fact.
So how in the world do you teach an AI to work like this? It's done with this really clever 3-stage training plan. First, each expert goes to a specialized boot camp with a hand-picked dataset to learn its core skill. Second, the router, the manager, is trained to figure out which tasks go to which expert. And finally, the whole team is trained together on a massive dataset, so they learn how to work together perfectly.
It all sounds great on paper, right? But does this brain-like design actually work out in the real world? Well, the researchers put it to the test.
Check this out. This is a perfect example. You give the AI this prompt. The router is smart enough to see the math part, 5 minus 2, and immediately sends that over to the logician. But then the second part, how does she react? That's a social question, so it routes that part to the socializer. The AI is literally breaking down the problem and delegating it to its specialists.
And the data totally backs this up. When they measured the socializer's activity, they found this really strong positive correlation, a value of 0.7, with how humans rated the social content of sentences. What that means is the socializer isn't just randomly firing off. It's getting active on exactly the right kinds of problems, in a way that just makes sense to us.
Okay, but here's the million-dollar question. Are these experts really essential for their jobs? I mean, are they just kind of along for the ride, or could the other experts just pick up the slack if one was missing?
To figure that out, they basically performed a kind of digital brain surgery. First, they tested the full model on a math test, and it did great. Then, they completely removed the logician expert, and the result? Whoa. Performance didn't just dip, it absolutely plummeted. This proves the logician isn't just helpful, it is causally essential for doing math.
And it's not just about getting the right answer.
It turns out this brain-like structure actually makes the AI behave more like us. On a test that measures how well AI behavior aligns with human behavior, the micro model scored way higher than a standard model. It doesn't just solve problems, it solves them in a more recognizably human way.
And honestly, here's the real kicker. You would think that adding all this structure and all these rules might hurt its performance, right? But it doesn't. Micro performs just as well and sometimes even better than the old unstructured models. We get all these amazing benefits, interpretability, human likeness, without sacrificing any power. It's incredible.
So what does this all mean for the future of AI? Well, this research is really pointing toward a whole new generation of AI that's not just smarter, but also safer and way more controllable.
So why does this matter so much? It really boils down to three huge things. One, it's way more transparent. We can finally pop the hood and see which expert is working on what, giving us real insight into its thought process. Two, it's more steerable. You want an AI that's less coldly logical and more empathetic? You can literally turn down the logician and turn up the socializer. And three, it's more cognitively grounded, meaning it solves problems based on a foundation that we can actually recognize and understand.
And as the researchers themselves put it, building AIs with this kind of brain-inspired specialization gives us models that are not only more human-like, but are also fundamentally more understandable to us humans. Which leaves us with a really fascinating final thought to chew on. By modeling artificial intelligence on the human brain, are we just teaching it to think more effectively, or are we actually teaching it to think more like one of us?